Light is everywhere, but does it leave a trace where it passes? Electrons create spirals, but after billions of years of sunlight and starlight reaching Earth, why don't we see light-carved corridors in the universe? In energy filament theory, the explanation centers on three key points. First, the electron's circulation follows a single rhythm, repeatedly pulling on the same section of the energy sea. An electron forms a closed loop, creating a stable flow. Over time, this continuous rhythm carves a directional spiral pattern, called the nuclear force knot. It leaves a trace because the rhythm is constant, the position is fixed, and the motion is uninterrupted. Second, sunlight and starlight, however, lack a unified rhythm. Sunlight and starlight are not monochromatic lasers. They consist of a mix of light filaments with different colors and rhythms. Each filament may briefly carve a pattern, but the next filament immediately switches rhythm or phase, preventing any single rhythm from dominating. This leads to a white noise effect where no fixed pattern can form. Third, the space is open, and any emerging patterns are disrupted by surrounding filaments. When one light filament manages to create a brief pattern, the next one quickly sweeps through and erases it, either by pulling in a different direction or by entirely disrupting the previous trace. Without a closed-loop circulation to sustain the pattern, and with constant disturbance from surrounding filaments, the pattern quickly fades before it can become permanent. Finally, what about intense lasers? Are they an exception? In fact, strong lasers offer a useful comparison. When a high-intensity laser with a single color, direction, and high coherence shines along the same path in air or gas for a long time, it does create the phenomenon of a light corridor. The beam self-focuses into a thin filament and temporarily carves a refractive index corridor. In terms of energy filament theory, when the rhythm is uniform, the direction is fixed, and the path is repeatedly brushed, the energy sea is temporarily carved into a textured corridor. Thus, electron circulation creates a trace because it follows the same rhythm on the same path. Ordinary sunlight doesn't because its filaments lack consistency. Only lasers with highly consistent rhythms and fixed paths can carve a temporary light corridor in the sea. Stay tuned for more in the series. Next episode, can light actually experience fatigue? Tap follow, share it on New Physics, Clear Universe.